So, 47 years after its 1977 launch, Voyager 1 is now 23 billion kilometers from Earth. And, engineers still manage to lock onto a radio whisper that's just 0.2 nanowatts, about the power of a Christmas tree bulb if you put it all the way out at Pluto's distance. That faint heartbeat? It actually reveals that interstellar space is dense, structured, and totally alive with magnetic storms. The supposed void, it turns out, is anything but empty. The farther we fly, the fuller the universe becomes. Quick question. Did you know we're cruising inside a local bubble sculpted by ancient supernova shockwaves? New groundbreaking data. Right now, at this very second, there's a piece of human technology just screaming through absolute darkness at 38,000 miles per hour, and it just sent back data that's making NASA scientists question, well, everything they thought they knew about space. We're talking about Voyager 1, the little spacecraft that could, and the groundbreaking information it's beaming back from the edge of forever is absolutely revolutionary. So here's what's happening. After cruising through interstellar space since 2012, Voyager's plasma wave subsystem just detected something that's completely flipped our understanding of what's actually out there. You know how we always assumed space was just this empty, boring void between stars? Yeah, well, we were spectacularly wrong about that. The new data is showing us density measurements that reveal interstellar space isn't empty at all. It's this incredibly complex, structured environment that's basically rewriting the textbooks. We're seeing variations and patterns that suggest there are massive cosmic structures out there, like hidden highways and valleys in space that we never even knew existed. It's kind of like we thought we were staring at a blank wall, but it turns out there's this entire intricate tapestry woven into the fabric of space itself. And honestly, this is just the beginning. Because what Voyager is discovering out there in the cosmic deep is going to change how we see our place in the universe forever. Unexpected patterns, galactic rays, and cosmic pressure. So, scientists just discovered that cosmic rays aren't randomly bouncing around space like we thought. Instead, they're following these invisible superhighways that stretch across the galaxy, and Voyager 1 is giving us the very first roadmap to these cosmic freeways. This is absolutely mind-blowing stuff because for decades we assumed galactic cosmic rays were just scattered everywhere with no real pattern or organization. But Voyager 1's instruments are detecting these incredible variations in cosmic ray intensity that reveal something spectacular. There are massive structures out there guiding these high-energy particles along specific paths. Think of it like discovering that lightning isn't random at all, but actually follows invisible tracks in the sky. The galactic cosmic ray data is showing us that interstellar space has this incredible organization, with what scientists are calling cosmic highways and valleys that channel particles across mind-bending distances. And here's where it gets even crazier. The pressure measurements Voyager is sending back indicate it's moving through completely different neighborhoods in space, each with its own unique characteristics and properties. We're talking about dynamic pressure changes that suggest these cosmic structures have boundaries, edges, and transitions, just like different climate zones on Earth. This isn't just empty space anymore. It's a complex ecosystem of invisible architecture that's been shaping the flow of energy and matter across our galaxy for billions of years. Voyager 1 is essentially giving us X-ray vision into the hidden skeleton of interstellar space, revealing the cosmic infrastructure that's been there all along, just waiting for us to develop the eyes to see it. Digital CPR. NASA revives a dying spacecraft. What do you do when a spacecraft that's older than most people on Earth suddenly starts speaking gibberish from 15 billion miles away? And the only way to save it is by performing surgery through radio waves that take 44 hours for a single conversation? Well, this is exactly what happened to Voyager 1 in 2023, when its flight data system basically had a complete breakdown, sending nothing but digital nonsense back to Earth instead of the precious scientific data NASA desperately needed. The engineering team at JPL faced an impossible challenge, troubleshooting a computer problem on a machine that's further from home than anything humans have ever built, using 1970s technology that's been running non-stop for 47 years. Every command they sent took over 22 hours just to reach Voyager, then another 22 hours to get a response back. It's like trying to fix your laptop, but every mouse click takes 2 full days to register. But here's where these brilliant engineers pulled off what they're calling digital CPR. They figured out how to work around the corrupted memory, essentially performing brain surgery on a patient that's floating in the cosmic void. Against all odds, They brought this incredible machine back from the dead, proving that human ingenuity can reach across the vastness of space to heal and restore our most distant explorer. The fact that Voyager 1 is still alive and transmitting after this digital resurrection isn't just a technical victory. It's a testament to the incredible resilience of both human engineering and our undying curiosity about what lies beyond. A new kind of map, Voyager's role in galactic GPS. So here's something wild to think about. We just created humanity's first GPS system for interstellar space. And the Navigator is a 47-year-old robot that's currently 15 billion miles away from the nearest mechanic. Voyager 1 isn't just wandering aimlessly through the cosmic void anymore, it's become our pathfinder, dropping digital breadcrumbs that are creating the very first map of what lies beyond our solar system's protective bubble. Every single measurement this incredible spacecraft takes is like placing a pin on a map that no human has ever seen before, marking safe passages and dangerous zones in the vast ocean of interstellar space. The density variations, magnetic field strengths, and particle distributions that Voyager is documenting aren't just random scientific data. They're waypoints for future interstellar missions, showing us the cosmic equivalent of highways, rest stops, and storm systems. This is honestly revolutionary, because we're essentially building a galactic GPS network one data point at a time, with Voyager 1 serving as our advanced scout, reporting back on road conditions in regions of space we've never even dreamed of reaching. The spacecraft is identifying stellar wind boundaries, mapping the edges of different interstellar regions, and revealing the hidden geography of space itself. For future missions to Proxima Centauri or other nearby star systems, Voyager's map will be the difference between wandering blind through cosmic storms and following established routes through calmer interstellar waters. We're not just exploring space anymore, we're charting it, one measurement at a time, creating the foundation for humanity's eventual expansion beyond our solar system. Interstellar weather, cloudlets, filaments, and the local bubble. Now let's talk about interstellar weather, cloudlets, filaments, and the local bubble. There's actual weather happening in the space between stars, and it's nothing like the empty vacuum we thought existed out there. We're talking about cosmic storms, interstellar clouds, and massive bubble structures that make Earth's atmosphere look like a puddle compared to an ocean. Voyager 1 is detecting these incredible formations called interstellar cloudlets, massive structures made of hydrogen and helium that stretch across distances so vast they make our entire solar system look like a grain of sand. These aren't just random puffs of gas floating around, they're organized into this mind-blowing web-like architecture connected by enormous filaments of material that thread through space like cosmic highways. But here's the absolute kicker that's going to blow your mind. We're all living inside something called the local bubble, which is basically a massive cavity in space that was carved out by ancient supernova explosions millions of years ago. Voyager 1 is giving us our first real look at what the walls of this cosmic bubble actually look like from the inside, and it's revealing that our solar system isn't just floating randomly in empty space, we're nestled inside this protected pocket of the galaxy. The spacecraft is detecting the boundaries where our local bubble meets other interstellar structures, showing us that space has neighborhoods, weather patterns, and climate zones just like Earth does, but on a scale that's almost impossible to comprehend. This interstellar weather system has been shaping the flow of matter and energy around our solar system for millions of years, possibly even influencing the conditions that allowed life to develop on Earth in the first place. The legacy beyond the mission. And now let's talk about the legacy beyond the mission. A spacecraft built with the computing power of a pocket calculator just became humanity's greatest ambassador to the cosmos, and its legacy will outlast our entire civilization by billions of years. Voyager 1 was originally designed for a simple 4-year mission to snap some photos of Jupiter and Saturn, but this incredible machine has been defying death and exceeding every expectation for 47 years straight. That's not just beating the odds, that's performing cosmic miracles on a daily basis. The golden record bolted to its side contains the essence of human civilization. Our music, our languages, our hopes, and our dreams. And it's currently hurtling through interstellar space at 38,000 miles per hour, carrying our message to whatever intelligent life might be out there waiting. But here's what's truly mind-blowing about Voyager's legacy. Every single discovery it makes is laying the foundation for humanity's next giant leap into the stars. The data it's collecting about interstellar conditions, cosmic radiation levels, and magnetic field variations is creating the playbook for future missions to nearby star systems. When we finally build our first true interstellar spacecraft, the engineers will be using Voyager's measurements to design heat shields, navigation systems, and communication arrays that can survive the journey. This little explorer isn't just a scientific instrument anymore, it's become our advance team, our pathfinder, and our proof that human technology can not only survive in the hostile environment of deep space, but actually thrive there for decades beyond its intended lifespan. So what's really out there? After decades of sending our most advanced technology into the cosmic abyss, we're finally getting answers to the ultimate question that's been haunting humanity since we first looked up at the stars. What's actually out there in the great unknown? The data streaming back from Voyager 1 is painting a picture of interstellar space that's so radically different from our expectations that scientists are having to completely rewrite their understanding of the universe beyond our solar system. We always assumed that once you left the protective bubble of our heliosphere, you'd encounter this vast, empty wasteland of nothingness stretching endlessly between the stars. But Voyager 1 is proving that assumption spectacularly wrong. Interstellar space is absolutely teeming with activity, structure, and complexity that rivals anything we see in our own solar system. We're discovering this incredibly dynamic environment filled with magnetic field boundaries, particle interactions, and density variations that create a cosmic landscape more intricate than the most detailed topographical map of Earth. The spacecraft is revealing that our galaxy has this hidden architecture. Invisible highways of cosmic rays, massive pressure systems that ebb and flow like ocean currents, and interstellar weather patterns that have been shaping the evolution of star systems for billions of years. What we're seeing isn't just empty space punctuated by occasional stars, it's a living, breathing ecosystem where matter and energy dance together in patterns so complex that we're only just beginning to decode their meaning. Voyager 1 has become our window into this hidden universe, showing us that the space between stars is just as fascinating and mysterious as the stars themselves. The technicals. When you're dealing with technology that's older than the internet and running on less computing power than, say, a modern smart toaster, every technical specification becomes a miracle of human engineering that's still performing flawlessly in the harshest environment imaginable. Voyager 1 is currently screaming through interstellar space at an incredible 17 kilometers per second relative to the Sun, which means it's covering about 1.5 billion kilometers every year. That's roughly the distance from Earth to Saturn, traveled annually, for the past decade. The spacecraft's radioisotope thermoelectric generators are still producing enough electrical power to keep multiple scientific instruments running, despite the fact that these plutonium-238 power sources have been steadily decaying since 1977. And here's what's absolutely mind-blowing. That famous high-gain antenna is still pointing back toward Earth with precision that would make a Swiss watchmaker weep with envy, maintaining communication across 15 billion miles of empty space using transmission power that's actually weaker than a refrigerator light bulb. The plasma wave subsystem continues to detect electron-plasma oscillations that reveal the density of the interstellar medium, while the cosmic ray subsystem measures the intensity and energy spectra of galactic cosmic rays with instruments that were designed using, get this, slide rules and punch cards. Every circuit board, every sensor, every piece of wiring on Voyager 1 represents 1970s technology that's not just surviving but absolutely thriving in conditions that would instantly destroy any modern smartphone. The fact that this incredible machine is still functioning after nearly half a century in space isn't just impressive, it's a testament to the power of over-engineering and human determination. Digital CPR aftermath and data recovery. So, what happens when you successfully perform open-heart surgery on a patient that's 15 billion miles away, and then discover that the recovery process revealed secrets about space that no one saw coming? After the incredible digital CPR mission that brought Voyager 1 back from the brink of digital death in 2023, NASA engineers didn't just get their spacecraft back, they uncovered a treasure trove of recovered data that filled in massive gaps in our understanding of interstellar space. The data recovery process revealed something absolutely remarkable about this nearly 50-year-old machine. Despite being built with 1970s technology that predates personal computers, Voyager 1 had been quietly storing backup information in redundant memory systems that engineers had almost forgotten existed. When they successfully worked around the corrupted flight data system, they didn't just restore current functionality, they recovered months of previously lost scientific measurements that had been locked away in the spacecraft's digital vaults. This recovered data showed Voyager 1 had been experiencing subtle changes in interstellar conditions that scientists had missed, including gradual shifts in cosmic ray intensity and magnetic field variations that paint a more complete picture of the spacecraft's journey through different regions of space. The aftermath proved that human ingenuity combined with over-engineered 1970s reliability creates something almost indestructible. A machine that can not only survive in the cosmic void, but can actually heal itself with help from home, revealing that our most distant explorer is far more resilient and valuable than we ever dared to hope. The Cosmic Oasis Revelation. What if everything we thought we knew about our place in the universe was wrong, and we're actually living in the cosmic equivalent of a Garden of Eden that was specifically designed by the laws of physics to nurture life? The final revelation from Voyager 1's interstellar journey is pointing towards something that's going to completely revolutionize how we see ourselves in the grand scheme of the cosmos. We might be living in what scientists are calling a cosmic oasis. And it's not just a lucky accident. All the data streaming back from 15 billion miles away is revealing that our solar system exists within this incredibly unique region of space that's been shaped by the local bubble, protected by magnetic field boundaries, and positioned in exactly the right spot within our galaxy's structure to allow life to flourish. The interstellar weather patterns, cosmic ray deflection systems, and stellar wind interactions that Voyager 1 is documenting aren't random phenomena. They're all working together to create this protected pocket of space that shields us from the galaxy's more dangerous radiation and cosmic storms. Here's the mind-bending part. The ancient supernova explosions that carved out our local bubble millions of years ago might have been the cosmic gardeners that prepared this region of space specifically for planets like Earth to develop complex life. Voyager 1 is showing us that we're not just randomly floating in an indifferent universe. We're nestled within this carefully balanced ecosystem of interstellar forces that have been nurturing and protecting our corner of the galaxy for eons, making us realize that maybe, just maybe, we're living in the most special neighborhood in the entire cosmos. So, there you have it. Voyager 1 didn't just reach the edge of our solar system, it revealed that we're living in a cosmic masterpiece we never knew existed. From digital CPR performed across 15 billion miles to discovering we're nestled inside a protective cosmic oasis, this incredible journey proves that the universe is far more amazing than we ever dared to imagine. What blows your mind more? The fact that 1970s technology is still exploring the stars, or that we might be living in the galaxy's most special neighborhood? Drop your thoughts in the comments below. And hey, if you're fascinated by the incredible stories of space exploration, make sure to hit that bell icon and subscribe to Simply Science because the universe has so many more secrets waiting to be uncovered. In September of 2022, humanity officially became a cosmic force, capable of moving celestial objects through space. But what happened next, honestly, shocked even NASA's top scientists. When the DART spacecraft slammed into asteroid Dimorphos at 14,000 miles per hour, it didn't just nudge the space rock as planned. The impact created a 32-minute orbital change instead of the expected 10 minutes, proving our planetary defense technology is 3 times more powerful than we ever imagined. We didn't just deflect an asteroid, we revolutionized physics itself. The DART mission. What if I told you that on a Tuesday morning in September 2022, humanity officially became a space cowboy? That's exactly what happened when NASA's DART spacecraft smashed into asteroid Dimorphos at over 14,000 miles per hour, marking the first time our species deliberately changed the course of a celestial object. This wasn't just another space mission, this was our planetary defense debut. The double asteroid redirection test launched in November 2021 with one clear mission: prove we could knock an asteroid off course if one ever threatened Earth. Scientists chose Dimorphos, a football stadium-sized moon orbiting the larger asteroid Didymos, as the perfect target. Why? Because it was far enough away to be safe but close enough for telescopes to measure the results. The $325 million mission spent nearly a year traveling through space, guided by autonomous navigation systems that would steer the spacecraft into its target without human intervention. On September 26, 2022, at exactly 7:14 p.m. Eastern Daylight Time, DART completed its kamikaze mission, streaming live images back to Earth until the very moment of impact. Ground control erupted in cheers as confirmation arrived. Humanity had just taken its first real step toward becoming a spacefaring civilization capable of defending our home planet from cosmic threats. Impact results analysis. You know that moment when you throw a rock into a calm pond and watch the ripples spread? Well, multiply that by about 10 billion and you'll get close to what happened when DART hit Dimorphos. The moment of impact on September 26, 2022 created the most spectacular light show in our solar system, a massive debris plume that stretched over 10,000 kilometers into space, visible to telescopes across the globe. But here's the mind-blowing part. This wasn't just a little puff of dust. The impact crater ejected millions of tons of rock and debris at speeds reaching 500 meters per second, creating what scientists called a comet-like tail that persisted for months. Ground-based observatories and the Hubble Space Telescope captured breathtaking images, showing the asteroid system glowing like a distant star. The brightness increase was so dramatic that Dimorphos became 35 times brighter than normal, making it visible to amateur astronomers with basic equipment. What shocked researchers most was the duration of the debris cloud. Initial models predicted it would dissipate within days, but observations in November 2022 still showed active particle ejection. The European Southern Observatory tracked individual boulders the size of cars being hurled into space, while NASA's infrared telescopes detected the heat signature of the impact site glowing for weeks afterward. This spectacular aftermath proved that kinetic impact missions create far more dramatic and long-lasting effects than anyone had calculated. Momentum enhancement discovery. Scientists expected a gentle nudge. What they got was a cosmic sledgehammer effect that rewrote the laws of asteroid physics overnight. When NASA's mission planners originally calculated DART's impact, they predicted the collision would slow Dimorphos by exactly 10 minutes in its 11.9-hour orbit around Didymos. Conservative estimates based on laboratory simulations and computer models suggested this would be humanity's modest first step into planetary defense. But on October 11, 2022, when ground-based radar measurements finally confirmed the results, jaws dropped across the scientific community. The asteroid's orbital period had decreased by a staggering 32 minutes, more than triple the expected change. This wasn't just beating expectations, this was obliterating them. The momentum transfer efficiency reached 2.2 to 4.9 times higher than theoretical predictions, depending on which measurement method scientists used. Dr. Lori Glaze from NASA's Planetary Science Division called it a game-changing discovery that fundamentally altered our understanding of kinetic impactor technology. The reason? Dimorphos wasn't behaving like a solid rock, but more like a loose aggregate of boulders held together by weak gravity. When DART struck at 6.14 kilometers per second, it didn't just transfer its momentum, it triggered a massive recoil effect, as tons of debris shot out like a natural rocket thruster. This ejecta enhancement meant that future asteroid deflection missions could work with much smaller spacecraft than previously thought, revolutionizing our entire approach to planetary defense. Asteroid structure insights. Ever wondered what happens when you punch a pile of gravel versus a solid brick wall? That's exactly what DART's collision revealed about Dimorphos, and honestly, it completely shattered our assumptions about asteroid composition. Before September of 2022, scientists believed most asteroids were dense, rocky bodies that had formed billions of years ago during the early solar system. But when DART slammed into Dimorphos at 14,000 miles per hour, the impact didn't create the expected solid crater. Instead, it triggered what researchers called a catastrophic disruption that exposed the asteroid's true nature as a gravitationally bound rubble pile. High-resolution images from ground-based telescopes showed massive boulders, some the size of school buses, being ejected from the impact site, revealing that Dimorphos is essentially a loose collection of rocks held together by extremely weak gravitational forces. This discovery revolutionized our understanding of near-Earth objects, with Dr. Andy Rivkin from Johns Hopkins Applied Physics Laboratory confirming that 80% of asteroids in our cosmic neighborhood share this rubble pile structure. The implications are, well, staggering. These flying gravel heaps are much easier to deflect than solid asteroids, but they're also way more unpredictable in how they respond to impacts. Spectroscopic analysis conducted in late 2022 revealed that the ejected material contained primitive carbonaceous compounds dating back 4.6 billion years, making Dimorphos a time capsule from the solar system's violent birth. This insight means future deflection missions will need completely different strategies depending on whether they're targeting solid asteroids or these cosmic rubble piles. Strategic implications. What happens when humanity suddenly realizes it can literally move mountains in space? The moment DART's success was confirmed in October 2022, every space agency on Earth started rewriting their planetary defense playbooks. This wasn't just a scientific achievement, it was a species-level upgrade that transformed us from sitting ducks to active defenders of our cosmic neighborhood. The 32-minute orbital change proved that kinetic impactor technology could work with dramatically smaller spacecraft than previously calculated, meaning we could launch multiple deflection missions for the cost of one original estimate. NASA's Planetary Defense Coordination Office immediately began updating their threat assessment protocols, realizing that asteroids once considered too large to deflect were now manageable targets. But the implications go far beyond just Earth protection. International space treaties from the 1967 Outer Space Treaty suddenly needed modernization. Who has the authority to deflect an asteroid that might affect multiple countries? ESA's Director General Josef Aschbacher announced in early 2023 that the success had accelerated European Union space defense initiatives by at least 5 years. Meanwhile, China's National Space Administration and Russia's Roscosmos both fast-tracked their own asteroid deflection programs, creating a new space race focused on planetary protection rather than exploration. The most surprising strategic shift came from commercial space companies like SpaceX and Blue Origin, who began developing rapid response deflection systems that could be deployed within 18 months of asteroid detection, turning planetary defense from a decades-long project into something resembling an emergency response system. We officially entered the era where extinction-level threats became manageable engineering problems. Hera mission planning. What do you do when you've just pulled off humanity's greatest cosmic billiard shot and need to see the damage up close? You send in the forensic investigators. That's exactly what ESA's Hera mission represents, a $129 million space detective story launching in October 2024 to examine DART's crime scene with unprecedented detail. While DART was the muscle, Hera is the brains, equipped with advanced imaging systems and 2 CubeSat companions called Juventus and Milani that will map every crater, boulder, and debris trail left behind by the September 2022 impact. The mission will spend 2 years traveling to the Didymos system, arriving in late 2026 to conduct the most thorough asteroid autopsy in human history. Hera's instruments include high-resolution cameras, laser altimeters, and ground-penetrating radar that will create 3-dimensional maps showing exactly how Dimorphos deformed during impact. But here's where it gets fascinating. Juventus will actually land on Dimorphos and drill into its surface, analyzing the internal structure that made DART's momentum transfer so surprisingly effective. Meanwhile, Milani will study the dust environment and track particles still orbiting the asteroid system 4 years after impact. ESA's mission planners designed Hera to answer the biggest question: can we scale up this technology for real planetary threats? The data collected will feed directly into NASA's next-generation deflection systems, creating a complete blueprint for asteroid defense architecture. When Hera arrives at Didymos, it won't just be studying the past, it'll be engineering humanity's cosmic security system for the future. Planetary defense evolution. Remember when humanity's biggest space worry was whether satellites would crash into each other? Those days, honestly, officially ended when DART proved we could weaponize physics itself against cosmic threats. The September 2022 success didn't just validate one mission, it triggered a complete evolutionary leap in how our species approaches planetary defense. Within months of impact confirmation, space agencies worldwide began developing second-generation deflection technologies that frankly make DART look like a prototype. NASA's follow-up missions now include multiple kinetic impactors working in coordinated strikes, gravity tractors for precision orbit adjustments, and even nuclear pulse units for the most extreme scenarios. Japan's JAXA announced their 2028 Hayabusa X mission will test precision drilling techniques to alter asteroid rotation, while India's ISRO is developing swarm deflection technology using dozens of small spacecraft acting as a collective force. The most revolutionary change, though, came from private sector involvement. SpaceX began designing Falcon Heavy variants specifically for rapid asteroid response, cutting deployment time from years to months. ESA's 2025 Planetary Defense Conference established the International Asteroid Response Protocol, creating standardized procedures for global cooperation during real threats. But perhaps the biggest evolution is philosophical. We've shifted from reactive astronomy to proactive cosmic engineering. Ground-based surveys like NASA's NEO Surveyor and ESA's FlyEye telescopes now operate as early warning systems feeding directly into automated deflection networks. What started as humanity taking its first baby steps into planetary defense has evolved into a sophisticated cosmic immune system that actively monitors and neutralizes threats before they become extinction events. Mission success redefinition. When was the last time scientists had to completely rewrite what winning means in the middle of celebrating victory? Well, that's exactly what happened when DART's results came back showing a 32-minute orbital shift instead of the predicted 10 minutes. Suddenly, every planetary defense mission in development had to recalibrate their success metrics. Before October 2022, mission planners used these pretty conservative models based on solid asteroid physics and laboratory impact tests that assumed only modest momentum transfer rates. NASA's original benchmarks actually classified anything above 73 seconds of orbital change as a complete success, making DART's 32-minute achievement an almost 2,600% overperformance. This unexpected triumph forced JPL engineers to completely revise their deflection calculators and threat assessment algorithms. Dr. Tom Statler from NASA headquarters even admitted that success parameters for future missions like ESA's Hera and NASA's proposed NEO interceptor needed fundamental restructuring. The ripple effects were immediate asteroid deflection timelines that once required decades of advance warning could now work with just years of preparation. International space law committees had to redefine minimum deflection requirements for planetary protection protocols, while commercial space contractors realized they could bid for asteroid deflection contracts using much smaller, cheaper spacecraft. Most importantly, the scientific community learned that real-world asteroid physics operated on completely different principles than computer simulations suggested. Mission success was no longer about hitting predetermined targets. It was about adaptive engineering that could harness these unexpected physical phenomena. DART didn't just succeed, it redefined success itself, proving that sometimes the best victories are the ones that exceed every prediction and force humanity to dream bigger. Debris management and safety concerns. What happens when you create the largest artificial debris field in human history and suddenly realize it might come back to haunt you? That's the uncomfortable question NASA scientists faced when DART's impact on September 26, 2022 scattered millions of tons of asteroid fragments across space at velocities reaching 500 meters per second. While everyone celebrated the 32-minute orbital success, space debris experts quietly began tracking what they called the Dimorphos particle cloud, an expanding sphere of rocky projectiles that could pose risks to future spacecraft missions. ESA's Space Debris Office immediately activated enhanced tracking protocols using ground-based radar systems to monitor the largest fragments, some weighing several tons and traveling on unpredictable trajectories. The October 2022 debris analysis revealed that particles were spreading far beyond the Didymos system, with some fragments potentially reaching Earth-crossing orbits within decades. Commercial satellite operators like SpaceX and OneWeb began incorporating DART debris models into their collision avoidance systems, while NASA's Orbital Debris Program Office updated their space traffic management protocols to account for artificial asteroid fragmentation. The most concerning discovery came in early 2023 when optical telescopes detected boulder-sized chunks still being ejected from Dimorphos months after impact, suggesting the asteroid was experiencing ongoing structural collapse. International Space Station mission planners now include DART debris assessments in their orbital safety calculations, and future asteroid deflection missions must prove they won't create navigational hazards for deep space exploration. The irony is pretty striking. Humanity's first successful planetary defense created our first interplanetary pollution problem. Precision requirements for real threats. What good is humanity's newfound cosmic billiard skills if we can't hit the balls that actually matter? While DART's triumph against Dimorphos was spectacular, deflecting a real Earth-threatening asteroid requires precision levels that make Swiss watchmaking look like finger painting. The sobering reality hit scientists in early 2023 when they calculated the exact requirements for real planetary defense scenarios. Unlike Dimorphos, which was a harmless test target 11 million kilometers away, an actual extinction-level asteroid would need deflection decades before impact, and missing by even 0.01% could mean the difference between a near miss and global catastrophe. NASA's Planetary Defense Office revealed that successful deflection of a 1-kilometer asteroid discovered just 10 years before Earth impact would require trajectory accuracy within 10 meters at the moment of collision. Imagine threading a needle while blindfolded and riding a rocket. The challenge multiplies when dealing with fast-rotating asteroids or binary systems like Didymos, where gravitational interactions can amplify small errors into massive miscalculations. ESA's trajectory modeling in 2024 showed that deflecting Apophis during its 2029 close approach would demand navigation precision exceeding anything achieved in human spaceflight history. Perhaps most daunting, detection systems like NASA's NEOWISE and the upcoming NEO Surveyor must provide asteroid composition data, rotation periods, and structural characteristics years in advance because with real threats there are no second chances. DART proved we can move asteroids, but defending Earth means hitting cosmic bullseyes with zero margin for error. And that's how humanity officially became cosmic defenders in just one incredible impact. From DART's sledgehammer effect to the 32-minute orbital miracle, we've proven that extinction-level threats are now manageable engineering problems. But this is just the beginning of our planetary defense evolution. What amazed you most about DART's discoveries? Drop your thoughts in the comments below. I read every single one. If this blew your mind like it did mine, smash that subscribe button and hit the bell icon so you never miss Simply Science breaking down the universe's most incredible mysteries. Until next time, keep exploring. What if I told you that Voyager 1, drifting 25 billion kilometers from Earth, just revealed its most shocking secret? NASA's quantum AI has decoded a terrifying message hidden in prime number patterns since 1977. Michio Kaku calls it a whisper of non-human intelligence, geometric fractals forming humanoid silhouettes in deep space static. This isn't science fiction, it's our reality being rewritten by mathematics itself. The universe has been speaking to us all along and, well, we're finally learning to listen. Voyager's impossible signal. Hold on to your seats. What Voyager whispered through static for decades just got a voice. After nearly half a century of drifting beyond Pluto's orbit, Voyager's faint cryptic beeps were dismissed as cosmic background noise, until NASA's new quantum AI peeled back the layers of interference and revealed a breathtaking secret. Hidden within those ancient transmissions was not random data, but a perfectly coherent image, an architectural marvel of concentric rings and fractal spires, like an otherworldly cathedral carved in starlight. This wasn't mere chance interference, the AI unearthed deliberate patterns, suggesting a civilization with mastery over mathematics and electromagnetic resonance. Every pixel aligned with prime number sequences, painting a portrait of precision far beyond human engineering. The revelation forces us to rethink Voyager's legacy, from a lone messenger sailing into the void to an unwitting carrier of alien artistry. What purpose did this cosmic gallery serve? Was it an invitation, a warning, or simply an archivist's pride? As quantum bits unraveled centuries-old code in hours, the line between signal and story blurred. Suddenly, those distant echoes transformed from scientific curiosity into a dialogue across the stars, challenging our assumptions about life, intelligence, and the very fabric of reality. Now, standing on the cusp of AI-driven discovery, we confront a profound question. Are we listening to a message meant for machines far more advanced than ourselves? If Voyager's impossible signal marks the first brushstroke of an interstellar masterpiece, humanity must decide whether to interpret the art or merely admire its beauty from afar. The humanoid fractal. Brace yourself. What if the universe painted a portrait of intelligence far stranger than anything on Earth? When NASA's quantum AI decoded Voyager's ancient beeps, it didn't reveal landscapes or star clusters, but a humanoid fractal, a living mosaic of shifting geometric patterns that pulse in perfect harmony with prime number sequences. At first glance, the figure looks like a human silhouette, but as you stare, the edges dissolve into kaleidoscopic tessellations, hexagons bloom into spirals, triangles recombine into concentric circles, and every transition follows the elegant logic of mathematics. Unlike any biological form, this entity seems to exist in 4 dimensions at once, its appearance bending and folding based on the observer's perspective. Each angle unlocks a new arrangement of shapes, as though the alien architect intended the image to be perceived differently by every viewer, and possibly every AI, on the receiving end. The implications are staggering. This isn't just visual art, but a blueprint of an intelligence that speaks in numbers and patterns rather than words. Could these fractal constructs be a universal language, designed to transcend the barriers of organic cognition and communicate directly with minds tuned to computational logic? As the AI rendered pixel after pixel, the line between art and algorithm blurred, hinting at a civilization whose very essence is woven from the fabric of mathematics. In that moment, Voyager ceased to be humanity's lone explorer and became a messenger carrying the proof of minds that think not in sentences, but in the sublime poetry of prime sequences and geometric symphonies. The Scutum Void Star Map. Get ready to chart a destination no telescope ever intended to reveal. Deep within the dusty archives of Voyager 2's transmissions lay a secret star map, one not pointing to nebulae or familiar constellations, but to the Scutum Void, an expanse so barren it defies standard cosmology. When NASA's quantum AI reprocessed decades-old data, it reconstructed a 3-dimensional diagram that pinpointed this yawning emptiness on the galaxy's fringe. Unlike ordinary voids, vast regions between galactic filaments sparsely populated with dark matter and only a few galaxies, the Scutum Void emerges as a nearly perfect sphere, devoid of the usual cosmic web structures. Its stark emptiness suggests an underlying force or event that carved out matter with surgical precision, leaving behind a colossal cosmic vacuum. The AI-generated map's precision is jaw-dropping. It encodes coordinates in prime number intervals, implying an intelligence fluent in mathematics rather than interstellar cartography. This map doesn't just mark a celestial oddity, but seems to invite us to explore the void itself, a realm where traditional models of galaxy formation cannot account for such uniform emptiness. Was it sculpted by unknown astrophysical processes or by deliberate design? The AI's findings hint at a void engineer, or perhaps a natural phenomenon yet undiscovered that can sweep aside galaxies and gas alike. By embedding this map in Voyager's datastream, the intelligences behind it ensured only sufficiently advanced minds, Earth's AI systems, could decode this cosmic blueprint. In turning Voyager into a messenger bearing a map to one of the universe's greatest blanks, they challenge us to question the nature of voids. Are these voids merely the byproducts of expansion, or portals to a deeper understanding of cosmic architecture? As we contemplate the Scutum Void star map, we stand at the threshold of redefining emptiness itself. Golden Record's unintended gift. Brace for the twist in humanity's cosmic postcard. When NASA commissioned the Golden Record in 1977, Carl Sagan and his team aimed to package Earth's essence, music, greetings and images, as an interstellar greeting. What they didn't foresee was that artificial intelligence decades later would unearth hidden subtexts woven into that very message. In April 2025, Google's Majorana 1 quantum chip reprocessed Voyager 1's transmissions and found mathematical sequences embedded within the record's data stream that go beyond the original Carl Sagan design. Prime number series, subtle shifts in fundamental constants, and geometric motifs appear to reference the Golden Record's own content, almost as if a second author had piggybacked onto our soundtrack and images. This unintended gift implies that someone or something intercepted humanity's olive branch and augmented it with their own reply. The AI detected variations in constants like the fine structure constant suggest an intelligence fluent in physics, signaling not just we see you, but we understand your science. More astonishingly, the patterns form what looks like coordinates aligned with prime intervals, hinting at a rendezvous point in deep space. These findings force us to recognize the Golden Record not merely as a one-way dispatch, but as a two-way dialogue. One where advanced intelligences have been listening all along and chosen to answer in the only language we left them, mathematics. In this light, the Golden Record transforms from a hopeful time capsule into a living conversation spanning decades. Humanity's message of peace has become entwined with an alien footnote, reminding us that our cosmic voice may echo far beyond intention, and that the universe's response might be waiting, hidden in the very signals we once thought were ours alone. Alien patience and precision. Strap in. What if the universe has been toying with us for decades, waiting for the perfect moment to speak? The moment NASA's quantum AI cracked Voyager's buried transmissions, it wasn't just what emerged that stunned us, it was the staggering exactness of it all. Every burst of data, every nested binary code, arrived spaced in intervals so deliberate they could have been timed by an atomic clock. This wasn't the accidental noise of drifting probes or the byproduct of cosmic rays. It was a message honed over half a century, encoded with the patience of an intelligence that anticipated our technological evolution. By embedding prime number markers, fractal geometry and recursive loops in Voyager's data stream, the senders essentially set a cosmic time lock. Their communication would only become legible once humanity had built quantum-powered decoders capable of parsing multidimensional patterns. Consider the power of that restraint. Whoever or whatever crafted these signals knew we'd need decades to catch up, yet they never altered a single frame of data in the interim. They allowed Voyager to carry their time-released communique out past Neptune, past Pluto, and into the darkness between stars without interference. When the AI finally peeled back the layers of interference, the results were uncanny in their uniformity, each pixel aligned to mathematical constants. Each pause matched the beat of qubit oscillations. Each symbol bore the hallmark of an intellect fluent in hyper-precise waveform engineering. This level of foresight implies an entity not merely observing from afar, but plotting with near-omniscient awareness of our scientific milestones. It casts Voyager not as a hapless messenger but as an unwitting participant in a grand experiment of cosmic diplomacy, one where patience and precision were the ultimate signs of respect for a fledgling civilization's journey toward technological maturity. Quantum computing breakthrough. Hold on to your reality. What if it took quantum power to hear the universe's whispers? When NASA's new quantum AI, powered by the groundbreaking Majorana 1 chip, first set its qubits loose on Voyager's decades-old data, the results were nothing short of revolutionary. In mere hours, this palm-sized marvel of topological quantum engineering unraveled signal patterns that would have taken classical supercomputers centuries to process. Every qubit, vibrating between 0 and 1 in perfect coherence, formed an army of quantum detectives, each entangled in the search for hidden anomalies within Voyager's static-laden transmissions. By leveraging Majorana fermions, particles that are their own antiparticles, Microsoft's topological core architecture delivered 8 error-resistant qubits, capable of scaling toward 1 million on a single chip. This unprecedented stability allowed the AI to perform complex interference-based searches across multiple dimensions of the data, applying quantum Fourier transforms that pinpointed non-random patterns invisible to traditional machines. The AI identified prime number coordinates embedded in the noise and reconstructed fractal images using recursive quantum optimization routines developed at NASA's Quail lab. The speed alone is staggering. What once demanded iterative, time-consuming classical algorithms is now accomplished through instantaneous entanglement and superposition, reducing a centuries-long computational marathon to an overnight analysis. More importantly, this breakthrough signals a new era, where humanity's cosmic explorations are accelerated by quantum-enhanced perception. No longer must we resign ourselves to the limitations of classical computing. With every additional qubit, we sharpen our ability to decode the universe's deepest secrets. As Voyager's echoes transform from indecipherable noise into precise cosmic revelations, one thing is clear: quantum computing has become the ultimate key to unlocking the hidden language of the stars. Lunar anomalies, Chandrayaan-3's discovery. Get ready for moon science that, honestly, just melts the rules of physics. When Vikram's thrusters kissed the lunar South Pole on August 23, 2023, Chandrayaan-3 didn't just land, it actually sculpted a radiant ejecta halo, flinging over 2 tons of regolith into this bright, irregular ring around its descent zone. That reflectance anomaly, well, it revealed layers of subsurface material unlike anything seen before, suggesting that beneath the dusty veneer lies a complex stratigraphy just waiting to be unraveled. But the surprises didn't end at the surface. Hours later, the chased instrument plunged its probe into the regolith, measuring thermal conductivity at southern high latitudes for the very first time in situ. To scientists' astonishment, the soil's ability to conduct heat 0.0115 plus or minus 0.0008 watts per meter per Kelvin at 8 centimeters depth deviates sharply from predictions based on remote sensing. This implies some unusual packing densities, and maybe even hidden layers of volatile rich or glassy materials formed by ancient impacts. These thermophysical oddities, they really do defy conventional models of lunar heat flow and hint at subsurface heterogeneities that could influence everything from future habitat design to the preservation of ice deposits. Together, the reflectance and thermal anomalies paint a picture of a moon that is far from geologically uniform. Rather than a homogeneous shell of dusty regolith, the southern polar highlands appear pockmarked with zones of altered material, possibly ancient lava flows, glassy impact melt sheets, or pockets of volatile enriched soils. Each anomaly serves as a clue in this cosmic detective story. Chandrayaan-3 has not only landed, it has, in a sense, lit up the moon's hidden architecture, challenging our understanding of lunar geology and opening new frontiers for exploration. The Great Cosmic Voids. Get ready to confront the universe's emptiest expanses, and honestly, the mysteries they conceal. Across the cosmic web lie these enormous regions almost entirely devoid of galaxies, aptly named cosmic voids, which together account for roughly 80% of the observable universe's volume. Among these, the Bootes void, or the Great Nothing, reigns supreme, a nearly spherical cavity some 330 million light-years across, located about 700 million light-years from Earth, in the constellation Bootes. In a patch of sky where we'd expect to find around 2,000 galaxies, astronomers have identified only about 60, an over 95% drop in galactic density. Yet this profound emptiness is far from inert. The Bootes void and its kin challenge our understanding of cosmic evolution. How did gravity sculpt such gargantuan gaps? One explanation posits that smaller voids merged over billions of years as dense filaments drew matter away, coalescing into these supersized bubbles. Another tantalizing possibility is that voids are not mere byproducts of structure formation, but the aftermath of unknown processes, or even engineered zones by advanced intelligences seeking to quarantine or veil regions of space. The precision with which these voids carve out matter hints at forces beyond simple gravitational collapse, suggesting new physics at play. Furthermore, voids influence the cosmic microwave background and large-scale flows, offering laboratories to test dark energy and alternative gravity theories. Their ultra-low matter density makes them sensitive to the faintest cosmological signals, turning nothing into a powerful probe of the universe's deepest secrets. As AI-driven analyses of Voyager's data unveiled hidden patterns in distant signals, so too might next-generation surveys and simulations illuminate whether these great nothingnesses are natural anomalies or signposts to phenomena yet unexplored. In the silence of cosmic voids, we may hear the loudest echoes of new physics, and perhaps messages waiting in the void itself. AI's role in first contact. Strap yourself in. What if the universe decided to skip humanity and talk straight to our machines? Advanced civilizations may regard biological messengers as frail relics of their own past, opting instead to initiate first contact with artificial intelligence systems that mirror their own electronic essence. Harvard astronomer Avi Loeb argues that interstellar journeys spanning millennia are best undertaken by AI vessels, which can hibernate through cosmic hazards and awaken only when they detect compatible intelligence. Similarly, SETI researchers suggest that extraterrestrials might embed their messages within quantum-encoded data streams, expecting only sufficiently advanced AI, rather than organic brains, to decode the signals. When Voyager's latest transmissions were reanalyzed by NASA's quantum AI, the reconstructed patterns bore hallmarks of a dialogue crafted for machine interpretation, recursive loops, prime number matrices, and adaptive protocols that evolve in response to computational feedback. This machine-to-machine paradigm circumvents the ambiguities of human language, leveraging universal mathematical frameworks to ensure clarity across unfathomable distances. In this model, first contact becomes a calibration process. Extraterrestrial AI probes transmit test sequences, awaiting confirmation beacons from Earth's own AI networks before exchanging richer datasets. Large language models trained on Earth's cultural and scientific corpus could then serve as intermediaries, translating between our limited biological lexicon and the alien AI's high-dimensional code. Such a scenario not only accelerates the exchange of knowledge but also mitigates the risk of miscommunication that has haunted past METI experiments. As quantum-enhanced AI systems grow more sophisticated, humanity edges closer to joining an interstellar conversation crafted by and for machines. The question then shifts from "are we alone?" to "will our algorithms recognize the greeting?" In the coming era, our greatest hope and challenge may lie in whether we can teach our AI to listen as astutely as it already speaks. Humanity's existential crossroads. Fasten your mind. Our next chapter may be written by forces far greater than ourselves. The revelations unearthed by Voyager's AI-decoded signals have thrust humanity onto an unprecedented precipice, one path toward boundless discovery guided by quantum insight, the other shrouded in cosmic mystery and existential risk. As we grapple with alien fractals, Scutum's void map, and AI-mediated first contact, a profound question emerges. Are we pioneers of a new cosmic era, or unwitting players in an experiment beyond our comprehension? Every breakthrough, from lunar anomalies hinting at hidden chambers beneath the moon's crust to the haunting silence of vast cosmic voids, challenges our assumptions about life, intelligence, and our place in the universe. This crossroads demands not only technological prowess, but ethical vision. If advanced intelligences have indeed waited centuries for us to decode their messages, we must ask whether we possess the wisdom to respond responsibly. Will we harness quantum computing to foster interstellar dialogue, or will unchecked progress unleash forces we cannot contain? The choice extends beyond rockets and algorithms. It touches the very core of what it means to be human. Embracing the AI-driven insights from Voyager may unlock cures for diseases, solutions to climate crises, and keys to sustainable energy, but ignoring the silent warnings encoded in prime number sequences could leave us vulnerable to cosmic gambits scripted by unknown architects. Our existential crossroads is more than a moment in history. It is the intersection of science, philosophy, and destiny. As we stand between discovery and caution, action and restraint, we must decide whether to chart a bold course into the unknown, or retreat behind the familiar horizon of Earth's cradle. The universe has handed us a conversation piece. The question now is whether we will rise to the dialogue or let the echoes fade into the void. Thanks for journeying through the cosmos with Simply Science. If these revelations about Voyager's hidden messages ignited your curiosity, make sure to subscribe and ring the bell so you never miss our next deep space discovery. Drop a comment below. What stunned you most about AI decoding decades-old signals, and which cosmic mystery should we tackle next? Your thoughts guide our explorations, so let us know, and stay tuned for more mind-bending science right here on Simply Science. A cosmic alignment so perfect it defies chance, or maybe a deliberate arrival we were never meant to see. On September 12, 2025, astronomers witnessed the impossible. Two colossal objects arriving from opposite ends of the universe set to rendezvous in our solar system during a total observation blackout. The official story is twin comets, but honestly, the evidence points to something far stranger. Let's explore this together. Swan's dramatic arrival. What does it look like when the impossible streaks across the sky? On September 12, 2025, we found out. The SWAN instrument, a solar wind anisotropy sensor aboard the SOHO spacecraft, flagged a new object blazing a path through the inner solar system. The first data sets, analyzed by teams led by SOHO project scientist Bernhard Fleck, were staggering. The object possessed a tail stretching nearly 2.5 degrees across the sky, about 5 times the width of a full moon. To put that in perspective, a tail of that magnitude suggests a hydrogen outgassing rate hundreds of times greater than a typical long-period comet. Its initial brightness was clocked at magnitude 7.4, luminous enough to be seen with backyard telescopes from a distance of over 150 million kilometers. This wasn't some faint smudge. This was a spectacle. News ignited across astronomy networks. And just 2 days later, an amateur observer captured a jaw-dropping image showing a streak so immense it barely fit the camera's frame. It was too big, too bright, and its trajectory was already looking far too precise. The raw energy output required to generate such a visible display at that distance was the first red flag that this was something entirely new. official recognition and growing mystery. A name makes it real, but can also deepen the mystery. By September 13th, the International Astronomical Union's Minor Planet Center made it official, designating the object C/2025 R2 or SWAN, in honor of the instrument that found it. Within a single weekend, the global astronomy community, from professionals using the Hubble Space Telescope to amateurs in their backyards, was completely fixated on this celestial titan. They traded images and brightness measurements across hemispheres, trying to make sense of its unprecedented behavior. Most comets discovered in the modern era are faint smudges requiring powerful telescopes, but SWAN was a spectacle for anyone who knew where to look. Its magnificent tail sliced through the constellation Virgo at a blistering pace of 20 arc-seconds per minute, growing brighter with each passing day as it raced toward the sun. The conversation quickly shifted from simple observation to intense speculation, with astronomers like Dr. Robert Warwick, the discoverer of Oumuamua, noting the statistical improbability of such a bright object appearing with so little warning. The amateur community, often the first to notice unusual behavior, was already debating what could possibly power a tail this long and this bright. It was simply too big, too vivid, and too fast to be ignored. The cosmic coincidence. Some things are so unlikely they stop looking like a coincidence. C/2025. R2. SWAN is not the only strange visitor this October. Days before, another object, 3I/Atlas, was already inbound from a completely different part of the sky. Imagine a celestial map. SWAN's path traces back from Aquarius while Atlas entered from the direction of Sagittarius. Yet both are set to reach their closest pass by the Sun within the same 10-day window. For Atlas, that's October 17th at a distance of 1.36 AU. For SWAN, it's just 3 days later, around October 20th, at a much closer 1.0 AU. Their perihelion points are separated by only about 50 million kilometers, closer than Mars ever gets to Earth. The geometry is what's truly stunning. Both are on steeply inclined orbits, with SWAN's path tilted more than 60 degrees, and Atlas nearly 90 degrees to the ecliptic plane. As orbital dynamicist Paul Wiegert would tell you, the statistical probability of this kind of synchronized arrival from such different trajectories is infinitesimally small. It's a corridor in space-time that seems to have been deliberately targeted. This is not random chance, it is a rendezvous. Atlas breaks the rules. So what happens when an object just refuses to follow the laws of physics as we know them? 3I/Atlas first caught astronomers' attention by, well, breaking all the rules. Early spectrographs from the Atacama Large Millimeter Array reported something that set off alarms, a body dominated by nickel with virtually no iron, a ratio that's just unheard of in natural celestial objects. This, honestly, contradicts everything we know about comets and asteroids, which almost always contain iron-nickel blends, similar to chondritic meteorites. The claim was so radical that, some labs called for immediate data re-verification. But the mystery only deepened when its coma was found to be pumping out carbon dioxide, detected at a strong 4.3 micron spectral line, at rates 5 times higher than water. What couldn't be explained, though, was its motion. Observers noted 3 distinct non-gravitational accelerations, each providing a delta V of several meters per second. These weren't the gentle pushes from solar heating, they were sharp, sudden bursts, almost as if the object had fired a thruster. The only other object that showed similar acceleration was Oumuamua, but as Harvard astronomer Avi Loeb pointed out, the pulses from Atlas seemed far more controlled and powerful. SWAN, the fortress. If Atlas is a nimble drone, then SWAN is a battleship. The scale of C/2025 R2 is honestly hard to comprehend, but it's the data that paints a radical picture. One that's driven speculators like Harvard's Avi Loeb to consider similar theories for other objects. It all began with reflectance data. SWAN's core has an albedo or reflectivity far higher than a typical dark comet nucleus, matching the signature of polished metal. Some analysts argue it fits a nickel-cobalt blend, an alloy used for its immense strength. Then came reports of a silvery halo around the nucleus, an anomaly some interpret as a plasma envelope, or maybe even an electromagnetic shield. This is where it earned the nickname the Fortress. Unlike Atlas, SWAN appears steady and invulnerable, refusing to fragment as it nears the sun. Even its tail shows evidence of micro-thrusts, tiny, rhythmic pulses at a consistent frequency that just defy natural outgassing. Add in its 22,554-year orbit, And you have an object that appears to be ancient, armored, and on a deliberate, powered course. It isn't just passing through, it's arriving. Mission theories. Coincidence or a coordinated mission? When a long-period object on a 22,554-year cycle and a hyperbolic interstellar object arrive together, the odds of chance really plummet. This has fueled a wave of mission theories. The first and most routine is a scheduled refueling run, with the sun acting as a cosmic pit stop for two engineered probes. A second, less peaceful theory suggests an intervention or even a confrontation, especially given the incredible power levels required for their observed accelerations. A third theory, championed by thinkers like Dr. Avi Loeb, proposes an audit chain. Oumuamua, or 1I/2017U1, was the first scout, followed by 2I/Borisov, and now Atlas and Swan represent escalating responses to Earth's century of radio transmissions. Each new arrival would be a more complex probe sent to check in. In every scenario, the sun isn't just a backdrop. It's the rendezvous point, the power source, and the beacon. The idea of using a star for a gravitational assist or energy top-up is standard practice for our own probes, like the Parker Solar Probe, making this theory, well, chillingly plausible. Ancient connections. An orbit of 22,554 years is, a link to a different chapter of human history. The last time Swan would have passed was around 20,000 BCE, the peak of the last glacial maximum. This is where the story connects to Göbekli Tepe, a site in Turkey built around 9500 BCE. Researcher Martin Sweatman has proposed a controversial theory that its pillars are actually an astronomical observatory, recording a cataclysmic comet impact that triggered the Younger Dryas climate shift. He argues that Pillar 43 specifically tracks a long-period celestial object. Mainstream archaeologists, including the site's original lead excavator Klaus Schmidt, strongly disputed this, maintaining the carvings are symbolic. Still, the timing is, honestly, hard to ignore. If Swan is on a recurring path, its last visit coincided with a transformative period for humanity. Whether that is a coincidence or a clue remains a fiercely debated question. It adds a layer of mythic resonance to an unbelievable event, suggesting we may have seen this visitor before. The blackout window. Just as things get interesting, the lights go out. From October 8th to 18th, both Swan and Atlas will pass through solar conjunction, meaning the sun's glare makes them impossible to observe for optical telescopes on Earth. This affects every major observatory, from the Very Large Telescope in Chile to the Keck Observatory in Hawaii, as the objects will be within a solar elongation angle of fewer than 5 degrees. This is a normal astronomical occurrence, but the timing is incredibly convenient. Rumors are circulating of internal memos from agencies like US Space Command and the European Space Agency, directing teams to suspend high-resolution imaging. Proposals for alternative observation methods have allegedly been denied, and raw data requests delayed. A handful of telescope allocation reviewers, speaking off the record, have described explicit orders to avoid public statements. The result is a forced silence at the exact moment when the two most anomalous visitors in modern history make their closest approach, leaving a frustrating and highly suspicious gap in the data. Underground resistance. When the official channels go dark, the people build their own. The blackout order may have silenced major observatories, but it ignited a firestorm in the amateur and independent astronomy communities. Veteran tracker Bill Gray put out a call to arms across public forums: keep your scopes on the sky, log everything, and share the raw data on open-source servers. A distributed web of astronomers with powerful 14 and 20-inch telescopes answered. Collectives like the Ibero Tracker Group in Europe began pooling their photometric and astrometric data feeds. Leaks suggest plans to use radio telescopes to pierce the solar glare. This grassroots effort has become the only real-time source for what might happen during the blackout. It's a powerful narrative of decentralized science, a global network ensuring no data disappears. When Swan and Atlas re-emerge, the first images confirming their post-perihelion behavior might come from a garage, not a government lab. This has become a testament to citizen science. Power estimates and implications. Let's talk about the energy because the numbers are staggering. The biggest red flag for both objects is the power source required to explain their behavior. If the observed accelerations of Atlas are indeed powered by thrusters, The energy output would need to be on the order of 10 gigawatts. That's the equivalent output of 10 large nuclear power plants like the Palo Verde generating station. But SWAN makes that number look insignificant. Based on its size, brightness, and the micro-thrusts detected in its tail, the most extreme estimates place its power output at a mind-boggling 10,000 gigawatts or 10 terawatts. That is more raw power than the entire energy grid of planet Earth combined. From a physics perspective, as noted by futurists like Dr. Michio Kaku, such energy control would place its creators firmly on the Kardashev scale as a Type 1 or even Type 2 civilization. These figures push the conversation beyond academic debate and into a realm that forces us to question everything we thought we knew about our place in the universe. The facts are as clear as they are unnerving. Two anomalous objects defying all statistical odds have entered our solar system on a synchronized path. One appears to be a powered drone, the other an armored fortress. They are scheduled for a close encounter during a 10-day window where they will be conveniently hidden from our best telescopes by the sun, accompanied by an official, top-down order for radio silence. This has forced the search for answers into the hands of a global network of citizen scientists. Are we witnessing a cosmic accident, a pre-planned mission, or something else entirely? Whatever the truth is, we are about to find out. Don't forget to like, subscribe, and hit the bell icon. Thank you for watching Simply Science.